Hi everybody, this is a video on solving 3x3 systems of equations. The following is a system of 3 equations and 3 variables. In order for a system to be solvable, there have to be at least as many equations as there are variables. The 3 variables we traditionally use are x, y, and z. So since I have x, y, and z, I must have 3 different equations. The solution to this system of equations is x equals 1, y equals 2, and z equals 8, and we're asked to verify that this is true. So we go one by one in each equation. For the first equation, I plug in 2 times 1 plus 2 minus 2 times 8, and I find that that equals negative 12. 3 times 1 minus 2 times 2 plus 8 does equal positive 7. And 2 times 1 minus 2 plus 8 does equal 8. That means that the ordered triple 1, 2, 8 is a solution to this system of equations. We can write that as 1, 2, 8, an ordered triple. One interesting use of matrices is to check a solution. So if we multiply the coefficient matrix, which is 2, 1, negative 2, 3, negative 2, 1, and 2, negative 1, 1, by our solutions, we find something very interesting. Now, make sure you remember how to multiply. We multiply 2 times 1, 1 times 2, and negative 2 times 8, and we add those together. That gives us negative 12. Then we multiply negative 3, positive 3 times 1, negative 2 times 2, and 1 times 8, and we add all those together, and we get 7. Finally, we multiply 2 times 1, negative 1 times 2, and 1 times 8. When we add all of those together, we get 8. We notice that this matrix matches up with the constants from our original equation, and our solutions match up to the matrix we multiplied by. So now we're going to learn how to how to solve a 3x3 system of equations. Most of the time, when we solve a 3x3 system, we use elimination. The idea is to eliminate a single variable in 2 different ways. This will reduce the system from a 3x3 to a 2x2. You already know how to solve a 2x2 system of equations. The best option for this system is to eliminate y in 2 different ways. The reason it is easier to eliminate y is because y has the simplest coefficients. So here are 3 ways we can eliminate y. I've labeled the equations a, b, and c for the ease of keeping them organized. I suggest you do this on all systems of equations. So if I add a plus 2b, I'm adding x minus 2y plus 4z equals negative 19, and 4x plus 2y minus 6z equals 28. When I do that, I have a result of 5x minus 2z equals 9. I've successfully eliminated y. Now, I have one equation that has 2 unknowns, so I'm going to have to try something else as well. I have to make sure I involve all 3 equations. So I can either combine the a equation and the c equation, or the b equation and the c equation. If I want to cancel out the y's, I can do a plus 2c, and get 7x plus 8z equals negative 9, or I can do c minus b. When I do that, I get x plus 5z equals negative 9. you could just as easily do b minus c and get a similar equation. I'm going to take two of those equations. I'm going to use c minus b because it gave me 1x. I find something that has 1x to be easier to deal with than, for example, the a plus 2c equation, which had 7x plus 8z. You can see it's just not very compatible with the other equations. So basically I've picked the simplest two equations. As you begin to practice this, you'll find that you don't need to use all three equations. You can just pick any two. So, I'm going to use substitution here. I'm going to take my x plus 5z equation, and I'm going to solve it for x. Then I'm going to plug it back in to the other equation. So when I do that, I get x equals negative 5z minus 9. If I plug that in and multiply by 5, I get negative 45 minus 25z minus 2z equals 9. When I solve that, I get z equals negative 2. Now, I can plug that back in to the c minus b equation and get x equals positive 1. Now that I know what x and z equal, I can plug them in to any of a, b, and c and get an answer for y. Do that now and solve this system. You should check your answers by plugging in like we did earlier. Okay, so you're going to try this one more or less on your own. The two equations that I want you to use are the first combination, 2a plus b, and the second combination, c plus 2b. Can you tell what variable we're trying to eliminate here? The correct answer is y. You can eliminate any variable you like, but y seems the easiest in this one because my coefficients for y are positive 1, negative 2, and 4. X and z are not much harder. You would have coefficients of positive 3, positive 6, and positive 1. Those aren't that challenging. And z has coefficients of negative 2, 1, and 3. I've just gone with y because I think those numbers are simplest. Okay, hopefully you've written down what 2a plus b are and what c plus 2b are. Once you've done that, you should be able to solve that 2 by 2 system of equations using tactics that you have learned in Algebra 1. Solve the rest of this system. If you're ready for the answer, here it comes. If not, pause. The answer to this system of equations is 1, 3, negative 2. Remember, that means x equals 1, y equals 3, and z equals negative 2. You can check that by plugging in 1 for all of the x's, 3 for all of the y's, and negative 2 for all of the z's. Okay, here's one for you to try completely on your own. Hopefully you're working with a partner. You can put your desks side by side and touching. You can have one person write with the pencil on the paper, moving one step at a time. If you'd like to, you can switch off steps. First, determine which variable you would like to eliminate. I think that there is a best answer to this question. Have you decided? I hope you've decided to eliminate y. We used y on the last problem, but that was just a coincidence. Okay, so combine your three equations. Remember, we want to label them A, B, and C, and we want to combine them. Alright, you should pause the video and try and work this through. The solution to this system of equations is x equals 2, y equals negative 3, and z equals 1. Did you use the equation a plus b to eliminate y? Did you use the equation c plus 2b to eliminate y? Those are what I consider to be the best first steps. You may have also used c minus 2a. I think using subtraction is a little bit more challenging. Okay, so now we're going to come to the special cases. The first one is an inconsistent system. You'll see what that name means in just a second. Here, we've decided to eliminate the x's. The x's have the nicest coefficients, so they're the easiest to go with. First, I've done a minus b. When I combine those, I get 5y minus 4z equals negative 2. Then, I've done negative 2a plus b. This is the same thing as saying b minus 2a. This gives me 5y minus 4z equals 0. I think you can see an inconsistency here. It's not possible for 5y minus 4z to both equal negative 2 and 0 at the same time. So this system of equations has no solutions. We get to stop our work here. The next is a system with infinitely many solutions. Now we have to be careful. When you solve an equation that has infinitely many solutions, we generally think of that to mean that there are all real number solutions. We have to be careful with systems of equations. So here, I've decided to eliminate the x's. I have done negative 3a plus c, and I got y minus 15z equals negative 13, and negative 2a plus b, and I got negative y plus 15 equals 13. When you look at these two, you realize they are just a multiple of negative 1 of each other. So we wouldn't say they're inconsistent. In fact, if we were to add them together, we would find that we get 0 equals 0. This is a true statement. So this is how we know that we have infinitely many solutions. Now, just because something has infinitely many solutions doesn't mean that anything can be a solution. So the way we figure out what one solution could be is we pick a variable and we give it a constant. So here I've let z equal the constant a. This seems confusing at first, but think of it as needing a place to start. If you want to, you can try this a couple times and let z equal 1. Then you could figure out what that would make y equal, and you could figure out what that would make x equal. I'm going to do that, but instead of using 1, I'm going to use a. So by plugging in a for z, I get that y minus 15a equals 13, and y equals 15a minus 13. So if my z value is a, then my y value is 15a minus 13. I'm going to go back to any equation. In this case, I'll use the first one since it is the simplest, and I'll plug in 15a minus 13 for y, and a for z. When I simplify that, I get x equals negative 23a plus 22. What does this mean, you ask? Well, this is called a general solution to a system of equations. Say, for example, I want to let my a value equal 1. This would mean that my system of equations has the following solution. X would be negative 1 because negative 23 times 1 plus 22 equals negative 1. My y value would be found by doing 15 times 1 minus 13, which is 2. And my z value equals a, which is 1. So negative 1 to 1 is one solution to this equation. Now say, for example, I wanted to use 0 for a. Then my solution to my equation would be 22, comma, negative 13, comma, 0. If you try either of those, you can find they work for the system of equations. Okay, I hope you enjoyed this video. Thanks for watching.